Welcome to Beyond the Stars, where tonight we turn our attention to the star that makes all life possible, the brilliant sphere of plasma that has illuminated Earth for 4.6 billion years, the source of warmth, light, and energy that sustains every living thing on our planet. This is not a sensational journey designed to overwhelm, but rather a peaceful meditation on the sun, exploring 100 calming facts about our nearest star as you drift gently toward restful sleep, allowing these solar mysteries to wash over you like warm sunlight on a quiet afternoon. The first fact about the sun is that it is classified as a G-type main sequence star, sometimes called a yellow dwarf, though it actually appears white when viewed from space. And this classification places it firmly in the middle range of stellar sizes and temperatures, neither the hottest nor the coolest, neither the largest nor the smallest, but a perfectly average star among the hundreds of billions scattered throughout our galaxy. The second fact reveals that the sun contains 99.86% of all the mass in our entire solar system, meaning that all the planets, moons, asteroids, comets, and dust combined make up less than 0.2% of the total. And this overwhelming dominance of mass is why the sun's gravity holds everything else in orbit around it. The third fact tells us that the sun is approximately 109 times wider than Earth, with a diameter of about 1.39 million kilometers. And if you could hollow out the sun like an enormous sphere, you could fit roughly 1.3 million Earths inside it, a staggering volume that speaks to the incredible scale of even an average star. The fourth fact is that despite this enormous size, the sun is not particularly dense compared to the planets, with an average density only about 1.4 times that of water. And this relatively low density results from the sun being composed primarily of hydrogen and helium gas in a state called plasma, where electrons have been stripped from atoms by the intense heat. And if this contemplative approach to solar science resonates with you, if these gentle astronomical facts help you unwind at the end of your day, we invite you to subscribe to Beyond the Stars and enable notifications so you can join us each week as we explore the cosmos through a lens of wonder and tranquility. And by subscribing, you support the creation of this thoughtful educational content. The fifth fact reveals that the sun is approximately 4.6 billion years old, born from the gravitational collapse of a giant molecular cloud along with the rest of our solar system, and it has been shining steadily for all that time, providing the stable energy source that allowed life to evolve and flourish on Earth over billions of years. The sixth fact tells us that the sun rotates on its axis, but unlike Earth, which rotates as a solid body, different parts of the sun rotate at different speeds in a phenomenon called differential rotation, with the equator completing one rotation in about 25 days, while regions near the poles take approximately 34 days to rotate once. The seventh fact is that the sun is not stationary, but orbits the center of the Milky Way galaxy, along with our entire solar system, traveling at about 220 kilometers per second, and it takes approximately 225 million years to complete one orbit around the galactic center, meaning the sun has completed about 20 such orbits since it formed. The eighth fact reveals that the sun loses approximately 4 million tons of mass every second through the conversion of matter into energy via nuclear fusion in its core. Yet despite this constant loss, the sun has enough hydrogen fuel to continue shining for another 5 billion years before entering the next phase of its stellar evolution. The ninth fact tells us that sunlight, the electromagnetic radiation that warms our planet and powers photosynthesis in plants, takes approximately 8 minutes and 20 seconds to travel from the sun's surface to Earth, covering the distance of about 150 million kilometers at the speed of light. The 10th fact creates our first moment of wonder. A photon of light created in the sun's core through nuclear fusion takes anywhere from 10,000 to 100,000 years or more to work its way out to the surface. bouncing countless times between particles in the dense solar interior, meaning the sunlight warming your skin today began its journey long before human civilization existed. The 11th fact brings us to the sun's layered structure. For our star is not a uniform ball of gas, but consists of distinct regions, each with its own temperature, density, and physical processes, and understanding these layers helps us comprehend how the sun generates and transports the energy that powers our entire solar system. The 12th fact reveals that at the very center lies the core, extending from the center to about 25% of the solar radius, where temperatures reach an incredible 15 million degrees Celsius, and pressures are so extreme that hydrogen nuclei are forced together in nuclear fusion reactions that convert 4 hydrogen atoms into 1 helium atom plus energy. The 13th fact tells us that this nuclear fusion process releases energy according to Einstein's famous equation E equals mc squared, where a tiny amount of mass is converted into an enormous amount of energy. And this is the power source that has kept the sun shining for billions of years and will continue to do so for billions more. The 14th fact is that surrounding the core lies the radiative zone, extending from about 25% to 70% of the solar radius, where energy produced in the core is transported outward primarily through electromagnetic radiation, with photons being absorbed and re-emitted countless times as they slowly work their way toward the surface. The 15th fact reveals that in the radiative zone, the density and temperature are still so high that matter exists in an exotic state, and it can take tens of thousands of years for energy to migrate through this region, because photons travel only a short distance before being absorbed and re-emitted in a random direction. The 16th fact tells us that beyond the radiative zone lies the convection zone, the outer 30% of the solar radius, where energy transport changes from radiation to convection, with hot plasma rising toward the surface, cooling, and then sinking back down in enormous circulation cells, much like water boiling in a pot, but on an almost incomprehensible scale. The 17th fact is that this convective motion creates the granular pattern visible on the sun surface when observed with telescopes, with each granule representing the top of a convection cell, and these granules typically measure about 1,000 kilometers across and last only about 8 to 20 minutes before dissolving and being replaced by new ones. The 18th fact reveals that the visible surface of the sun is called the photosphere, the layer from which most of the sun's light is emitted into space, and it has a temperature of approximately 5,500 degrees Celsius, which gives the sun its characteristic yellow-white color when observed through Earth's atmosphere. The 19th fact tells us that above the photosphere lies the chromosphere, a thin layer about 2,000 kilometers thick, that appears reddish during solar eclipses due to the emission of hydrogen alpha light, and temperatures in the chromosphere actually increase, with altitude rising from about 4,000 degrees at the bottom to over 20,000 degrees at the top. The 20th fact is that beyond the chromosphere extends the corona, the sun's outer atmosphere that stretches millions of kilometers into space and mysteriously has a temperature exceeding 1 million degrees Celsius. And while this might seem to violate the laws of thermodynamics, the corona's temperature represents the average kinetic energy of sparse particles rather than heat content. The 21st fact brings us to one of the sun's most visible features, sunspots, which are temporary dark regions on the photosphere caused by intense magnetic fields that inhibit convection and reduce surface temperature by about 1,500 degrees compared to surrounding areas, making them appear darker, though they would still glow brightly if seen in isolation. The 22nd fact reveals that sunspots can be enormous, sometimes larger than Earth, and they typically appear in pairs or groups with opposite magnetic polarities connected by loops of magnetic field lines that arc through the solar atmosphere, and complex sunspot groups can produce powerful solar flares and coronal mass ejections. The 23rd fact tells us that the number of sunspots visible on the sun varies in a regular cycle, averaging about 11 years from one maximum to the next, known as the solar cycle. And during solar maximum, the sun may have dozens or even hundreds of sunspots, while during solar minimum, it may have none at all for weeks or months. The 24th fact is that this 11-year cycle is actually half of a longer 22-year magnetic cycle, because during each 11-year period, the sun's overall magnetic field reverses polarity with the north and south magnetic poles switching places, and then it takes another 11 years to return to the original configuration. The 25th fact reveals that the sun's magnetic field is generated by the differential rotation of the solar interior, combined with convective motions in the convection zone through a process called the solar dynamo. And this complex interplay of rotation and convection creates the tangled magnetic field structures responsible for most solar activity. The 26th fact tells us that solar flares are sudden explosive releases of energy near sunspots, where twisted magnetic field lines reconnect, releasing the equivalent energy of millions of nuclear bombs in a matter of minutes and producing intense bursts of electromagnetic radiation across the entire spectrum from radio waves to gamma rays. The 27th fact is that coronal mass ejections are even more dramatic events where billions of tons of plasma are hurled into space at speeds up to several thousand kilometers per second, carrying embedded magnetic fields and enough energy to disrupt satellites' power grids and communication systems when directed toward Earth. The 28th fact reveals that the sun constantly emits a stream of charged particles called the solar wind that flows outward through the solar system at speeds typically between 300 and 800 kilometers per second, creating a bubble around the sun called the heliosphere that extends far beyond the orbit of Pluto. The 29th fact tells us that when the solar wind interacts with Earth's magnetic field, it can funnel charged particles toward the poles, where they collide with atmospheric gases and create the beautiful auroras known as the northern and southern lights, painting the sky with curtains of green, red, and purple light. The 30th fact is that the sun's magnetic field extends throughout the entire solar system through the interplanetary magnetic field carried by the solar wind, and the structure of this field resembles a ballerina's skirt because the field lines are pulled outward by the solar wind, while the sun's rotation causes them to spiral, creating what astronomers call the Parker spiral. The 31st fact brings us to the nature of sunlight itself, for the sun emits electromagnetic radiation across a vast range of wavelengths, from radio waves through visible light to X-rays and gamma rays, though most of its energy output falls in the visible and near-infrared portions of the spectrum that our eyes and skin can detect. The 32nd fact reveals that the sun's peak emission occurs in the blue-green portion of the visible spectrum at a wavelength of about 500 nanometers, and this peak wavelength is determined by the sun's surface temperature according to Wien's displacement law, one of the fundamental relationships connecting temperature and radiation. The 33rd fact tells us that despite this peak in blue-green light, the sun appears yellow or white to our eyes because it emits significant amounts of all visible wavelengths which our brains perceive as white light. And the yellow appearance we often see results from Earth's atmosphere scattering away some of the blue light, the same process that makes the sky appear blue. The 34th fact is that the total amount of energy the sun radiates into space every second equals approximately 3.8 times 10 to the 26th watts, an almost incomprehensibly large number equivalent to exploding 100 billion tons of TNT every second. Yet Earth receives only about 1/2 billionth of this total output due to our great distance from the sun. The 35th fact reveals that the amount of solar energy reaching Earth's upper atmosphere per square meter perpendicular to the Sun's rays is about 1,361 watts, a value called the solar constant, though it varies slightly with Earth's orbital distance and the 11-year solar cycle. The 36th fact tells us that about 30% of incoming solar energy is reflected back to space by clouds, ice, snow, and other bright surfaces, while the remaining 70% is absorbed by the Earth's surface and atmosphere, warming our planet and driving weather patterns, ocean currents, and the entire climate system. The 37th fact is that plants and photosynthetic organisms capture only a tiny fraction of the sunlight reaching Earth's surface, typically less than 1%. Yet this small amount of solar energy converted to chemical energy through photosynthesis forms the foundation of nearly all food chains and ecosystems on our planet. The 38th fact reveals that ultraviolet radiation from the sun, though comprising less than 10% of total solar output, is energetic enough to damage biological molecules including DNA, and Earth's ozone layer in the stratosphere absorbs most of the harmful UVC and much of the UVB radiation, protecting life at the surface from this damaging component of sunlight. The 39th fact tells us that solar radiation pressure, the physical force exerted by photons of light, is strong enough to push on objects in space. And this pressure drives the tails of comets away from the sun, can be used to propel solar sails for spacecraft, and even causes slight perturbations in satellite orbits. The 40th fact is that neutrinos, nearly massless particles produced by nuclear fusion reactions in the sun's core, stream through the sun and Earth in vast numbers, with about 65 billion neutrinos passing through every square centimeter of your body every second. Yet these ghostly particles interact so weakly with matter that they pass through the entire planet as if it weren't there, making them incredibly difficult to detect, but providing valuable information about processes occurring deep in the solar core. The 41st fact brings us to the sun's origin story, for our star formed approximately 4.6 billion years ago from the gravitational collapse of a region within a giant molecular cloud, possibly triggered by the shock wave from a nearby supernova explosion that compressed the cloud and caused it to begin contracting under its own gravity. The 42nd fact reveals that as this cloud collapsed, it fragmented into smaller clumps, with the largest central concentration forming what would become the sun, while the surrounding material flattened into a rotating disk from which the planets eventually coalesced. And this entire process, from initial collapse to the ignition of nuclear fusion in the sun's core, likely took only about 50 million years, a brief moment in cosmic time. The 43rd fact tells us that the sun began its life with a composition of about 71% hydrogen and 27% helium by mass, with small amounts of heavier elements, inherited from previous generations of stars that lived, died, and scattered their enriched material into the interstellar medium. And this composition has been slowly changing as nuclear fusion converts hydrogen into helium in the core. The 44th fact is that the sun has been gradually brightening throughout its lifetime, increasing its luminosity by about 30% since it first reached the main sequence. And this brightening occurs because as hydrogen is converted to helium in the core contracts and heats up, slightly increasing the rate of fusion reactions and energy production. The 45th fact reveals something remarkable about Earth's climate history. Despite the sun being 30% dimmer 4 billion years ago, geological evidence suggests Earth had liquid water and possibly even life at that time, creating what astronomers call the faint young sun paradox, likely resolved by a thicker atmosphere with higher greenhouse gas concentrations that compensated for the reduced solar heating. And if you're still with us on this gentle solar journey, we would be honored to have you subscribe to Beyond the Stars so you can explore more cosmic mysteries with us each week. The 46th fact tells us that the Sun is currently about halfway through its main sequence lifetime, the stable period during which it fuses hydrogen into helium in its core, and it will continue this phase for approximately another 5 billion years before the hydrogen fuel in the core becomes exhausted. The 47th fact is that when the core hydrogen is depleted, the Sun will enter a new phase of evolution, first expanding into a red giant star with a radius extending perhaps to Earth's current orbit, while its core contracts and heats until it becomes hot enough to fuse helium into carbon and oxygen. The 48th fact reveals that during the red giant phase, which will last for about 1 billion years, the Sun's outer layers will be quite tenuous and cool, glowing red rather than yellow, while the core burns helium in a series of increasingly unstable pulses that will eventually eject the outer envelope into space as a beautiful planetary nebula. The 49th fact tells us that after shedding its outer layers, the Sun's core will remain as a white dwarf, an incredibly dense object about the size of Earth, but containing roughly half the Sun's current mass, with no nuclear fusion occurring, but slowly radiating away its residual heat over trillions of years, gradually cooling and fading into darkness. The 50th fact is that this entire evolutionary sequence from main sequence star through red giant to white dwarf represents the standard life cycle for stars similar to the Sun, and by studying other stars at different stages of this evolution, astronomers have mapped out the Sun's past and future with remarkable confidence, allowing us to understand our star's place in the great cosmic story of stellar birth, life, and death. The 51st fact brings us to humanity's long history of solar observation, for people have watched the Sun since ancient times, tracking its daily motion across the sky, its annual path through the zodiac, and using its regular patterns to create calendars and mark the changing seasons that governed agricultural cycles and religious festivals. The 52nd fact reveals that the ancient Chinese recorded sunspots as early as 28 BCE, describing them as dark spots visible on the Sun's face. Though European astronomers initially resisted believing the Sun could have blemishes, considering it a perfect celestial object, until Galileo's telescopic observations in 1610 confirmed that sunspots were real features on the solar surface. The 53rd fact tells us that Isaac Newton conducted dangerous experiments looking at the Sun through his telescope, and even directly with his naked eye, causing temporary blindness and permanent vision damage, and his work helped establish that white sunlight is actually composed of all the colors of the rainbow, which can be separated by passing light through a prism. The 54th fact is that in 1814, Joseph von Fraunhofer discovered dark absorption lines in the Sun's spectrum, now called Fraunhofer lines, which result from cooler gas in the solar atmosphere absorbing specific wavelengths of light. And these spectral lines provided the first clues to the Sun's chemical composition, long before we had any direct samples. The 55th fact reveals that helium, the second most abundant element in the universe, was first discovered in the Sun's spectrum during the 1868 solar eclipse before it was ever found on Earth, and its name comes from Helios, the Greek god of the Sun, making it one of the few elements named after a celestial body. The 56th fact tells us that modern solar observation employs a vast array of ground-based and space-based telescopes observing the Sun at many different wavelengths, from radio waves to X-rays. And these observations must be conducted with extreme care, because the Sun is so bright that looking at it directly through a telescope without proper filters can cause instant and permanent blindness. The 57th fact is that numerous spacecraft have been launched specifically to study the Sun, including the Solar and Heliospheric Observatory, the Solar Dynamics Observatory, the Parker Solar Probe, and the Solar Orbiter, each carrying sophisticated instruments to measure solar magnetic fields, plasma flows, radiation, and other properties that cannot be observed from Earth's surface due to atmospheric interference. The 58th fact reveals that the Parker Solar Probe launched in 2018 is designed to fly closer to the Sun than any previous spacecraft, repeatedly diving through the corona to directly sample the solar wind and measure conditions in this extreme environment. And it uses a specially designed heat shield to withstand temperatures exceeding 1,400 degrees Celsius while keeping its instruments at room temperature. The 59th fact tells us that studying the Sun is not just an academic exercise, but has practical importance for understanding space weather, the term for solar activity that can affect Earth's magnetic field, satellite operations, power grids, radio communications, and GPS navigation. And improved solar forecasting helps protect technological infrastructure from potentially damaging solar storms. The 60th fact is that every culture throughout history has recognized the Sun's vital importance, creating myths, religions, and festivals centered on the solar cycle, from the ancient Egyptian sun god Ra to the Aztec deity Tonatiuh, to the summer and winter solstice celebrations found in nearly every human society, reflecting our species' deep understanding that the Sun is not merely another astronomical object, but the source of all warmth, light, and ultimately life itself on our planet. The 61st fact brings us to comparisons that help us understand the Sun's place among the stars. For while our Sun seems immense and powerful from Earth's perspective, it is actually a fairly average star, neither particularly large nor small, hot nor cool bright nor dim, when compared to the full range of stellar types scattered throughout the galaxy. The 62nd fact reveals that the largest known stars, hypergiants like UY Scuti or Stephenson 218, have radii more than 1,000 times larger than the Sun, so enormous that if placed at the center of our solar system, they would extend beyond the orbit of Jupiter, swallowing Mercury, Venus, Earth, and Mars entirely. The 63rd fact tells us that the most massive stars can exceed 100 times the Sun's mass, burning their nuclear fuel so rapidly that they live only a few million years before exploding as supernovae, while the smallest red dwarf stars may be only 8% of the Sun's mass and will continue shining for trillions of years, far longer than the current age of the universe. The 64th fact is that the hottest stars, blue supergiants and Wolf-Rayet stars, can have surface temperatures exceeding 40,000 degrees Celsius, more than 7 times hotter than the Sun, while the coolest stars, brown dwarfs and late-type red dwarfs, may have surface temperatures below 3,000 degrees cooler than some household ovens. The 65th fact reveals that approximately 3/4 of all stars in the galaxy are red dwarfs, stars smaller and cooler than the Sun, while only about 8% are similar G-type stars like our Sun, and less than 1% are the massive hot stars that eventually explode as supernovae. So despite being average, the Sun is actually more massive and luminous than the vast majority of stars. The 66th fact tells us that many stars exist in binary or multiple star systems, where 2 or more stars orbit their common center of mass. And while the Sun appears to be solitary, some astronomers have speculated about a distant companion star, sometimes called Nemesis, though no evidence for such a companion has ever been found. The 67th fact is that the Sun orbits the Milky Way galaxy at a distance of about 27,000 light-years from the galactic center, placing it in the galactic suburbs rather than in the dense, star-packed regions near the core, and this relatively isolated location may have been important for Earth's development because nearby supernova explosions or gravitational disturbances would have been less frequent. The 68th fact reveals that stars like the Sun make up a population called Population 1 stars, which are relatively young and metal-rich, formed from gas that has been enriched by previous generations of stars, while older Population 2 stars contain far fewer heavy elements and represent an earlier era of stellar formation. The 69th fact tells us that the Sun moves through space, not just in its orbit around the galaxy, but also with a peculiar motion relative to nearby stars. And this motion carries it through different regions of the interstellar medium, occasionally passing through denser clouds that may compress the heliosphere and potentially affect Earth's climate over millions of years. The 70th fact is that approximately every 36 million years, the solar system's orbit through the galaxy causes it to pass through the galactic plane where the concentration of matter is higher, and some researchers have suggested this might correlate with increased comet impacts or other astronomical events affecting Earth, though this hypothesis remains controversial and speculative. The 71st fact brings us to the profound connection between the Sun and life on Earth, for nearly every organism depends directly or indirectly on solar energy, from plants that capture sunlight through photosynthesis, to herbivores that eat those plants, to carnivores that eat the herbivores, creating food chains and ecosystems ultimately powered by our star. The 72nd fact reveals that photosynthesis, the process by which plants convert sunlight into chemical energy, has fundamentally transformed Earth's atmosphere over billions of years by producing oxygen as a waste product, changing our planet from an atmosphere dominated by carbon dioxide to one rich in oxygen that made complex animal life possible. The 73rd fact tells us that fossil fuels, including coal, oil and natural gas, represent stored solar energy from ancient photosynthesis created when plants and other organisms living millions of years ago captured sunlight and were later buried and transformed by heat and pressure, meaning that most of our modern civilization still runs primarily on ancient sunshine. The 74th fact is that the Sun drives Earth's water cycle by evaporating water from oceans, lakes and rivers, lifting it into the atmosphere where it condenses into clouds and falls as rain or snow, redistributing fresh water across the planet and shaping landscapes through erosion, while also moderating climate through heat transport. The 75th fact reveals that the Sun powers atmospheric circulation and weather patterns through differential heating, warming equatorial regions more than polar regions, and creating temperature and pressure gradients that drive windstorms and ocean currents, and all the dramatic weather phenomena from gentle breezes to hurricanes ultimately trace their energy back to solar heating. The 76th fact tells us that Earth's seasons result not from changes in distance from the Sun, but from the tilt of Earth's rotation axis, which causes different hemispheres to receive more direct sunlight at different times of year, creating the annual cycle of summer and winter that affects ecosystems, agriculture, and countless aspects of human life. The 77th fact is that the Sun's ultraviolet radiation, while potentially harmful in excess, plays beneficial roles, including stimulating vitamin D production in human skin, which is essential for bone health and immune function, and breaking down certain pollutants in the atmosphere, though proper sun protection is important to avoid overexposure. The 78th fact reveals that circadian rhythms, the internal biological clocks that regulate sleep-wake cycles, and many other physiological processes in humans and other organisms, are synchronized by sunlight exposure, particularly the blue wavelengths of morning light, and disruption of these natural rhythms through artificial lighting can affect health and well-being. The 79th fact tells us that solar energy technology, including photovoltaic panels that convert sunlight directly into electricity, and solar thermal systems that use sunlight to heat water or generate steam, represents humanity's attempt to harness the sun's power more efficiently, and while currently providing only a small fraction of global energy needs, solar power is growing rapidly and may become a dominant energy source in the future. The 80th fact is that every atom of carbon in your body, every breath of oxygen, you inhale, every drop of water you drink, and every calorie of food energy you consume connects you directly to the sun through chains of causation extending back billions of years, making you quite literally a child of our star, assembled from solar-processed matter and sustained by solar energy flowing through Earth's biosphere. The 81st fact brings us toward the conclusion of our solar journey by acknowledging what we still don't fully understand. For despite centuries of observation and decades of space-based solar physics, mysteries remain about our nearest star. And if you've stayed with us through these 100 calming facts, we would be deeply grateful if you would subscribe to Beyond the Stars, enable notifications, and share this video with others who appreciate peaceful astronomical contemplation. The 82nd fact reveals that the coronal heating problem remains one of solar physics' greatest puzzles, for the sun's corona has a temperature exceeding 1 million degrees, while the photosphere below it is only about 5,500 degrees, and how energy is transported upward to heat the sparse coronal plasma to such extreme temperatures is still not completely understood, despite numerous theories. The 83rd fact tells us that the exact mechanisms triggering solar flares and coronal mass ejections are still being researched, though we know they involve magnetic reconnection, where tangled magnetic field lines suddenly snap into new configurations and release enormous amounts of stored magnetic energy. The 84th fact is that predicting space weather, including when and where solar storms will occur and how they will affect Earth, remains challenging despite significant progress. And improving these forecasts requires better understanding of the sun's complex magnetic field evolution. And by subscribing to our channel, you help us continue creating this thoughtful educational content exploring cosmic mysteries. The 85th fact reveals that the solar neutrino problem, a decades-long mystery about why detectors on Earth measured only about 1/3 the expected number of neutrinos from the sun, was finally resolved by discovering that neutrinos can change between different types as they travel, a phenomenon called neutrino oscillation that has profound implications for particle physics. The 86th fact tells us that the sun's magnetic field becomes completely disordered and then reorganizes with reversed polarity every 11 years. Yet how this magnetic dynamo operates in detail and what determines the cycle's exact timing and strength remain active areas of research, with implications for understanding stellar magnetism throughout the universe. The 87th fact is that the sun gradually loses mass not only through nuclear fusion, converting matter to energy, but also through the solar wind, carrying particles away, and over its entire lifetime, the sun will lose a tiny but measurable fraction of its total mass, which will cause planetary orbits to expand slightly as the sun's gravitational pull weakens. The 88th fact reveals that in about 1 billion years, increasing solar luminosity will make Earth's surface too hot for liquid water to exist, likely ending the possibility of life on our planet's surface long before the sun actually becomes a red giant. Though this timeline is uncertain and depends on complex climate feedbacks we don't fully understand. The 89th fact tells us that the sun belongs to a generation of stars that formed from gas enriched by previous stellar generations and all the heavy elements in the sun-Earth. And our bodies were created inside earlier stars or in supernova explosions, meaning we are quite literally made of stardust, and we invite you to share this video with others who might find wonder in this cosmic connection. The 90th fact is that studying the sun helps astronomers understand other stars throughout the universe, for while every star is unique, they all follow similar physical laws, and the detailed observations we can make of our nearest star provide insights into stellar physics that would be impossible to obtain for more distant objects. The 91st fact reveals that the sun has been worshipped, feared, studied, and celebrated by every human culture throughout history, recognized universally as the source of light, warmth, and life. And this recognition of the sun's importance represents perhaps the most fundamental astronomical knowledge possessed by our species. The 92nd fact tells us that modern heliophysics, the study of the sun and its influence on the solar system, combines observations theory and computer modeling to understand solar behavior and its effects on space weather, planetary atmospheres, and conditions throughout the heliosphere. The 93rd fact is that future solar missions, including advanced space telescopes and probes that will venture even closer to the sun than the Parker Solar Probe, will continue revealing new details about our star's structure, dynamics, and behavior, and we encourage you to subscribe so you can learn about these discoveries as they unfold. The 94th fact reveals that the sun will continue to be humanity's primary energy source for the foreseeable future, whether indirectly through fossil fuels and biomass, or increasingly directly through solar power technology. And understanding our star remains essential not just for scientific knowledge, but for practical applications affecting human civilization. The 95th fact tells us that every sunrise represents Earth's rotation, carrying your location into view of the sun, and every sunset carries you back into shadow. And this daily cycle has marked the passage of time for life on Earth for over 3 billion years, creating rhythms and patterns that shape ecosystems and human cultures. The 96th fact is that the sun's light takes about 8 minutes and 20 seconds to reach Earth, meaning we always see the sun as it was 8 minutes ago. And if the sun suddenly vanished, we wouldn't know for over 8 minutes until the last photons reached us and darkness fell. The 97th fact reveals that looking at the sun through its reflected light off the moon or planets, or through its effects on Earth's atmosphere in phenomena like rainbows, halos, and sunsets, allows us to appreciate its beauty, safely reminding us that the sun's power demands respect, even as we marvel at its gifts. The 98th fact tells us that the sun represents not an eternal, unchanging fixture, but a dynamic, evolving star in the middle of its life, and contemplating its history and future helps us understand that change is fundamental to the universe, and that even the most permanent seeming features of our world are temporary on cosmic timescales. The 99th fact is that humanity's relationship with the sun, from ancient sun worship to modern solar physics, from agricultural calendars to space weather forecasting, from solar mythology to solar energy, technology represents our ongoing effort to understand and harness the power of our nearest star. The 100th and final fact brings us full circle to the beginning. The sun is a yellow dwarf star, one among hundreds of billions in our galaxy. Yet it is our star, the one that birthed our solar system, that warms our world, that powers life on Earth, that has shone steadily for 4.6 billion years and will continue shining for billions more. And as you drift into peaceful sleep tonight, may you rest easy, knowing that tomorrow the sun will rise again, continuing its ancient cycle, sharing its light and warmth freely with our small blue world. And we thank you for joining us on this calming journey through solar facts. We invite you once more to subscribe to Beyond the Stars, to comment with your thoughts about our magnificent star, to share this video with fellow skywatchers, and to return next week as we continue exploring the gentle wonders of the cosmos together. And now, as sleep embraces you, may you dream of golden sunlight, of warm summer days, of the steady, reliable presence of our star that makes all life possible. Good night. and may the peaceful light of the sun illuminate your dreams.